Good evening, friends. Hope you're doing well tonight. I almost got an early start today, but for better or for worse, I got a new headset yesterday. Yeah, that was yesterday. And so I had a few little technical challenges getting it set up. But I think it should be good. My levels could be a little different, but I think everything looks pretty stable. So hopefully this goes fine in that regard. And well, hopefully it goes great in every regard. Always hope for that. But anyway, yeah, I'm ready to do some more space engineers. I'm ready to do some more AI, Project Sentinel, all that fun stuff. Um, I kind of I ended off the space engineer section last time, not really knowing exactly what I wanted to do next, but I've managed to think through some of that and got a bit of a plan for what to do. That'll be nice. I was also thinking about the fact that I wanted to make kind of, some of the information that I'm talking about a little more accessible. Not everybody necessarily knows what I'm talking about with the different algorithms and pieces of them. I tried to explain some of it, but also this is a live stream. Not everybody's going to catch a whole spiel at the beginning. So I kind of want people to ask if they got questions about it. I mean, this may be, well, it will be available in video format afterwards, but you know, I want, I want people to understand, and I'm excited about all this, and I want people to be excited about it too, or at least have that potential. Um, and actually, to that end, I guess this should work. I set up a couple commands like I added in the stream description, but mainly probably should have tested this before the game started. No worries, worked perfectly. That looks like a lot more of a wall of text than I intended, but oh well, should be fine. But yeah, it's exactly that. I'm hopeful that people are interested, and I'm more than happy to explain it. So yeah, should be great. Um, yeah, let's open up the. That was the right world, right? Yeah, that's it. A-star testing. Good, good. Open up the world, and I've got a plan. Got a plan. And I mean, it's anybody's guess as to how well I stick to the plan, but that's neither here nor there. I'm sure it'll be fine. All right. Back in game. And I guess we're back in game so that I can immediately tab out of the game and go over to Visual Studio instead. I guess that's the actual goal. Right. Bye, Twitch Studio. Except hello for 1 second so that. Right, that's that way. I want to go this way. Want Visual Studio to be big. And let's see. So we were looking at. Oh, good. Oh, right. Yeah, I made a few little code changes in here while I was messing around. What did I add? I added a. Oh, I added the epsilons. Yeah, okay. That's fine. Oh, that was last time. I didn't add that off stream. Cool. Okay, yeah, so we were looking at the heuristic function and what I need to change to to make this work. For a ship that is going to break and slow down to 0, or more specifically slow down to some target velocity, but usually that's going to be 0. But basically, yeah, I want to be able to route a ship so that it not only reaches a specific point in space, but is also going at a specific velocity when it reaches that point. The most important one being 0, because it's much more productive to dock your ships gracefully at the station's connector rather than just smash it in, because that's usually not going to be a good way of transferring your resources or whatever it is you need to do. So I'm pretty sure what I would need to start with. Honestly, I think I'm going to end up. A lot of this is just going to be rewritten, but it's going to be related. So we'll see. We'll still start with the goal vector and the goal unit vector. Those are useful. We're going to want those. But I was right, or I'm pretty sure I was right. I do need to take into account all of the thrusters on the ship, and I need to group them by axis. Because the way I was calculating things before, I was looking at only the thrusters that were, would thrust my ship in the direction of the goal, because they're the only ones that I'm going to actually care about. But now we're looking at the potential of the thrusters that move the ship in the direction of the goal, as well as the ones that move in the opposite direction, because the shortest time to get from point A to point B is going to be to accelerate to the fastest speed you can possibly go up until the last moment when you have to turn on the brakes and slow down until you hit your target velocity instead. So I'm going to need the thrusters in both directions. So that's first goal. Fortunately, the thrusters can only be... Oh, okay. So I'm going to say this, and it's going to be true for now. The thrusters can only be pointed along 3 axes, because for now, I'm just going to assume there are no thrusters attached to rotors or the new turret blocks, because that's going to make my math hard as hell. So we're just going to pretend those don't exist right now. That's a problem for another day. Right now, assuming all thrusters are attached securely to the main grid of the ship seems plenty complicated enough. Yikes. All right, I guess I could make a note of this. I made a couple comments up here that yeah, let's not do that. So yeah, I originally, when I wrote the first iteration of this, I based my guess just on the time it would take if the ship were already traveling at max speed in the correct direction, which is a admissible heuristic, meaning that using that does still allow the A-star algorithm to find an optimal path. But it turns out doing that is super inefficient. It makes it really slow, which is a problem when you have the limited computing capacity of the in-game scripts in Space Engineers. So when I added in, I'm looking at my actual current velocity, and I calculate, the time it actually takes to ramp up and then travel at max velocity, assuming we even hit it before we hit the goal. And that made the thing so much more efficient, because it was a much more accurate calculation to what the ship's actually going to do, while still being admissible. And then I had already thought about the fact that I would next want to account for slowing down. And that's what we're going to do now. So anyway, how do I want to name these? So we're gonna have 3 axes. I mean, I guess I can just name them like front, right, and up, and base them on the thruster's orientation relative to the main grid. Relative, I mean, I guess it's to the controller's orientation. That's right, right? Sorry, I know you guys can't see this. I don't think you can. No, I could pull it out, I know. But I'm looking at some of the documentation for the orientation functions. Because actually, maybe this is what I want. Oh, some of the methods in here are really difficult to read. So there's a method for getting the world matrix that can be used to get its forward direction relative to the world coordinate system, which is what I'm doing here. Like I'm looking at the backwards is the direction that the ship will move, the thruster is on, and so this vector is actually a vector in the world's 3D space. But there should be a property that can just get me the direction relative to the grid it's in. Cube grid. Well, that's just going to get me information about the grid it's in, not... I think, because there is an orientation property. I think that might have what I need. I actually might have to just test this. I think it's going to be a little messy to test, but it's probably the right thing to do. Okay, sure. Let's see. Do I want to do this in this world? Or should I go to another world? It's probably easier to do this in another world. Yeah. I mean, I could, because the thing is, I don't have any, like, well, I guess I could just make a copy of the test ship. No, I could do it here. That's fine. Okay, here, let me switch you guys back over to the other picture-in-picture mode. I will just make a copy of this ship. I will come to a stop, because if I'm moving... Well, I guess it's got its... whatever the word is that tries to slow it down. on. What is the word for that? That's going to bug me. Hold on. Inertial dampeners. Inertia dampeners. That's, yeah. So, yeah, if you paste a ship in while you're moving, the ship will move at your speed. But the inertia dampeners are on, so I guess it would have stopped anyway. Anyway, all right, so I want to go, I should still write this in here because it'll be easier. Oh, damn. Okay, I don't really want to create a new class project. That seems like, actually, maybe that's not a waste of time. Maybe that's a very valid use of time. Okay, let's show you, in case you care. I'm going to, so this is all thanks to the magic of the Visual Studio plugin that Malware created to make coding scripts in Space Engineers really easy. I'm going to add a new project. There you go. All right, and we'll look under the, oh wait, no, this is just right, yeah, in-game script. We're gonna call it, I'm just gonna call it Sandbox. Because I'm not planning on this code sticking around. Yeah, that all looks fine. I'm not planning on this code sticking around. I just want to use it to test some things out. So this creates a new project in here right alongside my A-star ship, tests, welder, and brain. Most of these I don't really care about. Actually, I am going to just remove some of the comments for clutter. I'll leave the constructor here for now. I'm not going to mess with the save method. One day, the save method lets you like keep track of data in between like the world stopping and starting, which long term I really would like to have because I'd actually like to have ships that remember what they're doing if the server turns off and then comes back on. But at the moment, I'm not worried about that. Just really looking at the short-term stuff, so that's fine. Okay, so what I want this script to do, I'm probably not going to use the constructor, but I'll leave it there. I'm going to want a list of thrusters, which have the type IMyThrust. I think I just want to make this a new list. That's the shortcuts in Visual Studio are just a little bit different than the IDE I use at work because I don't code in C# at work, I code in Java. Things are a little bit different. I mess up my hotkeys sometimes. So yeah, if I remember right, just make a list of thrusters. We do, it's grid terminal system, there we go, grid terminal system dot get blocks of type, and you can add the type IMyThrust here, but it also gets inferred if I just pass it the type thrusters. So this will look at all the blocks on the grid that the programmable block is running on, and get all of the blocks that are of the IMyThrust type, since I'm passing it in a list of IMyThrust, and it will add those blocks to this list. So now I have a list of thrusters. And then I can do for each thruster in thrusters. That's the syntax. Good. I'm getting my for each syntax down in C#. That one really throws me. I can echo, which will print logs out to the programmable blocks little screen. I'll show you where that is. Let's see, I want to echo the thruster's name, which I believe is the one I want is display name text. think that's right. I'll double check that in game in just or actually I'll double check that in my old script in just a second. So I'm gonna echo the name. Actually, an echo is one line, and so I'm gonna echo the name and then the orientation. So colon sure plus thruster dot orientation returns orientation object. I think orientation dot forward is what I want it to say. I think that's right. Okay, let me real quick check. I think it's in my A-star class. I've got a no, didn't use it there. I put it in. It would make sense if it were in the command. Thrusters. Here we go. Yeah, display name text is what I liked to use. So display name text. Yeah, so this should do. So I can do the whole like export the script thing here and import it back in the game, but because this script is so tiny, I'm just going to copy this since that's all I need. Still much easier to type the code in Visual Studio than in game. So much easier. Edit. We'll just do control A. Get rid of it. Got our main function. Check code should compile. Good. Oh, I can switch you guys back to the main view. I don't know if it's worth the constant swapping, but people will let me know if they love it or hate it. So that should do what I want. And then we'll run, and here's we go. Good. No, that's exactly what I want. That's perfect. That's perfect. So now I can just look at the thrusters and for the purpose of grouping them, I can just group them by orientation dot forward. Perfect. All right, let's switch back here. I'm gonna go ahead and close this because I don't need it. Not that it matters what I have selected over there, but okay, cool. Here we go, back in heuristic function. All right, so first thing, group my thrusters. And I think, yeah, I could group them into 6 groups. I think I'm just going to group them into 3 though, and just do the axes. If that turns out to be really bad, I'll change it up. But that's fine. So I have a list of my thrust. We'll call it forward. Yeah, I don't think that'll be too confusing. New list. We'll have a list of my thrust called up. And we'll have a list on my thrust called right. Okay, and then we will go through each thruster for each on my thruster in all thrusters. If thruster dot orientation forward equals the base, yeah, equals the direction forward, or the orientation forward is backward, then I don't need braces around this. Then we'll add it to forward. Forward dot add. There we go. Thruster. And then actually, let's just copy this. Yeah, hell, we can just copy the whole thing. That's fine. So we'll do this 3 times. Else. So look at up and wait. Oh, shoot, not that forward. That forward needs to stay the same. Check it against up and down. We'll add it to our up list. And if we check it against right or left, we'll add it to our right list. Actually, you know what? If it's not forward, not backward, not up, and not down, it has to be right or left. So there is no reason to do that evaluation. There is no return result for orientation.forward that is not one of those 6. So might as well do that. All right. Then we have our collection of thrusters that are on the forward-backward axis, the up-down axis, and the right-left axis. And I don't actually care which directions in space those are, or even which directions on the ship those are. I just care that I'm looking at all of the right thrusters at the same time. So that's essentially our equivalent of what I was doing here before, where I was looking at the significant thrusters. And so now I'm going to look at, actually, let me think. This would actually be easier if I add, because again, it doesn't actually matter what forward, up, and right are. I don't care which one is which at this point. I just care that they're grouped correctly. So I just want a list of the lists. That's those 3 lists, if that made any sense. Come on, give me that one. Yep. Axis groups. Excuse me. Let's see. Can I just do this in C#? Forward, up, right. Does that work? Something like that, right? Can only use array initialize. Oh, you can use that to create arrays, not lists. That's fine. This can be an array. That works just as well. And that's, yeah, no, that's fine. Okay. So just have an array of lists of thrusters going forward, up, and right. That's totally fine. There's probably a nicer way to do this, but I do think this kind of makes it easier to keep straight. So I'll leave that. All right. And I can still do a for each loop. So axis, yeah, I'll just call, oh wait, for each list, my thrust, call it axis in axis groups. Great, still for each through that, good, perfect. Because I'm going to use the same exact logic on each of the 3. Actually, yeah. I would like to initialize these same variables for this one. Let me put a comment here before I get way out of line. Just call this. There. So I remember that all that stuff is the old version, and because I'm going to lose track of exactly where my break is. You know what? This could probably use way more. I'm super blind. That looks terrible. There, that looks fine. All right. Now, I wrote some of this out, right? So I group the thrusters in each axis. So okay. Before, I would look at a single thruster, and I got the direction in space that that thruster would push the ship, and then projected the goal onto that direction. That's fine. That makes sense. I can do the same here. Oh, something I should do. It's possible, it's not going to happen with our current ship, but it's possible that a ship could have 0 thrusters on one of these axes. That's actually another interesting thing. That's another limitation that the built-in remote control autopilot has, is I believe it will not allow you to initiate autopilot if you don't have at least 1 thruster in every direction. Mine will, or at least that's the plan. So it's theoretically possible that one of these could be empty. So I think we're just going to group this whole thing. Is that fine? Axis. Just have a built-in like is empty call. No, that's fine. Axis dot count is 0. Well, actually is greater than 0. If it is 0, we want to skip it. Yeah, there. I hit Control Enter, not Shift Enter. All right. So we only want to mess with it if the count is greater than 0. If the count's less than 0, we can't do anything on that axis anyway, and a bunch of my calls are going to fail because I'm going to start referencing elements of the list. All right. So the count's 0. We're going to evaluate this axis. This algorithm is going to totally break at the moment if there's not thrusters in every direction. Well, if you need to go in that direction anyway. But I suppose that's correct. You kind of want it to fail if you can't get there with the ship's configuration, so that's fine. All right, so the first thing is basically the same thing here. I need to find the direction of the goal for the axis I care about. So to start, I can look at any one of the thrusters on this axis. So I'll just pick the first one in the list. And yeah, we're gonna look at this stuff. Okay, so let's call it vector 3D, call it axis goal direction. We're gonna do axis 0, so the first thruster in the list. Dot world matrix dot backward. So that is the direction in space that the first thruster in this list will move the ship if it's fired. But there's a chance that that's actually away from the goal and not towards the goal. So we need to check, which is basically going to be the same check I did before to check if the thruster was quote unquote significant. So if goal unit vector dot axis 0 world matrix, axis 0 world matrix backwards is just x goal here, is greater than 0. Actually, I want to check if it's less than 0. Then axis goal deer times equals -1. So what the dot product does, why are you, oh, because I'm not using you yet, that's fine. I will, don't worry. Don't you worry, Visual Studio. So if the goal unit vector, the dot product of the goal unit vector and our axis direction is positive, that means they are less than 90 degrees apart, which means the ship would be moving in roughly the same general direction as the goal. If it's less than 0, that angle is more than 90 degrees and the ship would be moving further away from the goal, which means the direction of the goal on this axis is actually in the opposite direction, which is exactly just this vector, the negative of this vector. So there we have that. Now we have a correct axis goal direction. All right. So, and then I want this. Same thing. Vector 3D projected axis goal is vector 3D dot project on vector ref goal vector ref axis goal dear. So this is going to take our goal position in 3D space and project it onto our our current axis. So essentially, the goal's got 3 parts, and the only part that this axis of thrusters can do anything about is to try and reach this point. It can't get us the rest of the way there. The other 2 axes are going to have to worry about that. It can only worry about this part. So this is the only part we care about. It makes the math much easier. So now we have our projected goal. Now, the new thing is we also have a target velocity. State, good. Right, obviously. Okay. And we need to also calculate, and the velocity's got the same thing as the position. It's got 3 parts to it, but there's only one part that this axis can do about. And so we're going to have each axis care about its own part of the velocity separately, just like it's doing the position. So we're going to have to project our velocity onto our thruster vector as well. So first, that means we need our current velocity. Yeah, that seems right. So we're going to need a vector 3D of projected current velocity is vector 3D dot project on vector, and this is going to be we want to project the current state's linear velocity onto this axis. Yep. And the projected, if I can type, goal velocity is going to be same thing. Projecting the goal is, where was I getting that from? Goal state is the name. Cool. Goal state, which will have its own linear velocity, and project that onto our current axis. Perfect. Okay. Check, check. Can I check these off? I guess I could have made this an actual checklist. That's fine. It's not that long of a list. I've got a OneNote window open on my other monitor now. I'm not even looking at Space Engineers. I do have Visual Studio as the main screen, right? Good. So, all right. Next thing I want to do is calculate time to go from max speed to target. Oh, to target speed. Yeah. All right. All right. Oh, I do have a typo there. Velocity. Yeah, double. I'm gonna want the actual linear speed too. Projected goal speed is projected goal velocity dot length. Is length the method? It is. I can't keep track which things are. Clearly, I can start to keep track which things are methods and which things are properties. It's confusing as hell. Got to admit. All right, it feels inconsistent in the, but also I don't know. I didn't create the API I'm working in, so I don't know. It's fine. It's weird in Java sometimes too, but most everything is accessed as a method in Java, so it feels more consistent. Anyway, there's also a chance that the projected goal speed is negative. If if uh, if the target velocity is not 0, it could actually be towards where the ship currently is, which does mean that the ship is actually ultimately going to have to fly past its goal and back, because that's the only way to get a velocity going in that direction. But that's a job for the algorithm to figure out. Right now, I'm just telling it it's going to take more time because the projected speed is negative. And so to determine that, we'll do a quick if projected goal velocity dot axis goal direction is, oh, hold on. Oh, this is fine. I'm gonna do this and then I'm gonna come back to my question. If it is less than 0, which, well, yeah, if it's less than 0, projected goal speed, make it negative. So projected goal velocity should actually be exactly 1 if it's in the same direction, and it should be exactly -1 if it's in the opposite direction. Because I've already projected it there, so these vectors are parallel, or they're actually, there's even another word for that, because they are the same vector or opposite vectors. They should actually be exactly the same. Well, they could have different lengths, but yeah, they're on the same axis. They're all on the same axis. So it should actually be 1 if they are in the same direction, and -1 if they're in the opposite direction. But rounding error means they might not actually be 1 or exactly 1 or -1. One of them could, however, be 0. In fact, it's very, very possible that the correct projected goal velocity is 0. That's going to be my common case at the beginning. And I think 0 dot something is still totally valid. There's nothing wrong with that, right? This isn't going to tell me that. Let me just dot product 0 vector. Like that's just fine, right? It's going to result in 0, which is fine. Yeah, you can put 0. Okay. I was just making sure I'm not like crashing the whole thing. It's been a long time since I've done actual vector math, so that's fine. And if it is 0, it doesn't matter if we multiply this by -1 or not, because the speed is also 0. Yeah, and if the axis goal direction is 0, then we're literally on the goal, so there's nowhere to go anyway. So either we're already there or our target speed is 0, so multiplying this by -1 in either case makes no difference. Okay, now we have speed. Speed's correctly signed. All right, so I want to know, the next thing I decided I need to note in order to get this is if the ship was already at its maximum speed, how long would it take to decelerate the ship from its maximum speed down to the target speed? And the reason for why we need that will become clearer, hopefully, as I continue down. But yeah, so did I hopefully already have one of my kinematics equations put in here that will give me that. So I want time yeah, this is what I want. I want the time it takes to go from this speed, the initial speed, to the final speed with a given acceleration. Which means first I have to calculate the acceleration. Yeah, that's fine. All right, so probably before I do that, I should group my thrusters, because I have all of these thrusters that are on the current axis, and some of them are pointing in one direction and some of them are pointing in the other direction. And now that I have determined the direction of our goal, I can figure out which of those thrusters belong in which group. And I think I was going to have to do this anyway, so doing that determination based on whether they were started out forward or backward probably isn't a big deal. Like, it optimizes it a little bit if you've got like 30 thrusters. If they've got all the forwards together and all the backwards together, you can check one of each group and be like, okay, this one's good, so this whole group is good, the other one's whole group is bad. But so much is going to change about this before I actually care about that's an optimization I can do later. Right now, I think, yeah, figuring it out here is fine. So that means we're going to have 2 more lists of thrusters. This is a lot of calculation for a heuristic function. But again, we're not doing optimization now. We're just trying to get it working. All right, so we have one list of thrusters that's going to be what should we call them? We could call them gas thrust and brake thrust. Calling them gas and brake seems bad. I could call them forward and backward, but that's confusing because forward and backward are used elsewhere in this kind of context. I actually kind of like gas and brake. Just gonna call them gas. Yeah. Yep. New list. Thrust. Brake. That kind of brake. So for each I might thrust thruster in axis, if thruster dot, oh, sorry, thruster world matrix backward dot axis goal direction is greater than 0, then it's gas. So this means, thruster will matrix backwards is the direction in space that my thruster, that the ship will move when the thruster is fired. And if that is in the direction of the goal, it's gas. Add thruster. Else, brake, add thruster. In this case, dot product should never be 0. This literally can't be 0 unless something's broken. And again, if this is 0, we're on the goal. This whole thing is moot. I think. Okay, I will admit there's a chance we're on the goal and not going the right speed, which makes this whole thing a mess. I think it theoretically still works though. I don't know. I'm really not sure. But in theory, yeah. Is there a better way I can do this? Is there a better way I can do this? Because if they, like I said, rounding error means it's probably not ever going to be 0, 0. But if this vector was actually 0, it can be, right? Old matrix. Oh, wait, no. Oh, hold on. This is a direction. This can't be 0. This is just a direction. The goal unit vector, that could be 0. And that assigns this arbitrarily to a direction, but this is still a direction. This can't be 0. Never mind. Then we're great. We're great. Yeah. The projected axis goal, that could be 0. Okay, no, I feel much better about this. Okay, no, we're good. Because yeah, what I was worried about was that if this actually ended up somehow being actual factual 0, we would actually add all of the thrusters to the same group. And that would definitely mess with the math, but yeah, should be fine. All right, I like that. I think that's fine. Should I put in comments in here? Just as a reminder, because I'm going to come back and look at this and be confused as hell as to what we're doing. Yeah. Let's see. Determine goal vector. Goal position vector. Yeah, that's fine. Group thrusters. Yeah, that's sufficient. Just little hints to myself when I come back and forget what my old self did. Okay, so now we have the two groups of thrusters. Now, would we be capable of the time it required to go from maximum speed to the target speed? I think so. Because now we have our brake thrusters so we can calculate our acceleration. That's what I want. That's what I want. So, double brake thrust is 0. For each my thrust. this could definitely be optimized because I could do this in this loop. Let's do that, actually. Let's do exactly that. Hold on, I'm going to write a double for gas thrust. I guess max gas thrust, to be clear. And double max brake thrust. Come on, fingers, work with me. All right. So we add a thruster to one of the groups, and then we'll do max gas thrust plus equals thruster dot max effective thrust. Yeah. And max brake thrust, same thing. Perfect. Yeah, that's much cleaner. All right, so now we know the maximum thrust we can get if we fire all of our braking thrusters at once, or all of our gas thrusters at once too, which is also going to be important. All right, and we'll divide that by the mass of the ship. Ooh, okay, no, that's fine. We'll do that in a sec. All right, so we have this kinematics equation. This is the one I want. So the time it takes, yeah. So I'm gonna have a double time from max speed to target speed. This is a super concise variable name we've got here. Equals kinematics dot get time delta v. We need an initial speed, which is, I didn't actually properly calculate. Projected current velocity. I actually should also have a projected current speed, which is the projected current velocity dot length, but again could be negative, so I have to do this same check. Projected current speed dot projected velocity dot axis goal direction is less than 0, then projected current speed is negative 1. Thank you. Okay. Technically this same equation could apply with vectors instead of scalars. But it's going to come up with the same result. And so, I don't know. I think it's fewer operations to do it this way, to just convert to lengths. I mean, doing the dot product checks are, I'm not going to worry about it. We'll do it down the line. I'm going to say that a lot. So our initial speed is projected current speed. Final speed is projected goal speed. And the acceleration is the max braking thrust. That should already be in the right direction. Oh, actually, no. That's always going to be a positive number because the max effective thrust is positive. We know this is negative, so the max. Oh wait, I don't want projected current speed. Sorry. We're trying to get time from max speed. Max speed is, oh good, I have a constant. Here we go. Max ship speed to projected goal speed. Yeah, I was getting ahead of myself and thinking like, wait, this could actually be less than that. Sorry. Max ship speed, projected goal speed. The acceleration is the max braking thrust divided by the ship mass, which we calculate by controller dot mass dot. No, it's not controller dot mass. It's controller dot ship mass. Calculate ship mass. So method physical mass. Physical mass is what I'm using, right? Yeah, that's what I've been using. And then we also need to multiply this by -1 because these are braking thrusters. So we're going from 100 meters per second, it's the maximum ship speed, down to something less than that. Our acceleration has to be negative. So the thing I realized I wanted to do was this calculate ship mass actually calculates 3 different masses. There's a base mass, a physical mass, and a total mass that are described as the base mass of the ship, the physical mass of the ship accounting for inventory multiplier, and the total mass of the ship including cargo. I'm still not certain which of those is the most accurate one to use. I'm pretty confident it's not base mass. But the descriptions are confusing as hell, and that's something I need to do some more experimentation with. I know when I'm in a ship, they evaluate differently. When I'm checking a ship that I'm not in, I think some of them are actually the same. But at any rate, they can change easily, so I want to just add a simple little helper function here called get ship mass. And I'm going to just have it return. I probably should give it a return value. Double. Actually, they might all be floats. I don't know. We'll see in a sec. And we're just going to have it return controller. Oh, it's not. This can't be static. It needs access to controller. Return controller dot calculate ship mass, and we're going to have it read physical mass right now. It is in fact a float. I'm usually using doubles anyway because I'm used to just using doubles for everything, but might as well. This is a float. That might as well be a float. So this way I can change this, and it'll just change it everywhere if I'm using this in multiple places, which I probably am. Right now, oh yeah, even right now I am. Okay, so yeah, place this. Get ship mass. Where did I go? Oh, I'm already, yeah. Wow, I've already written more than I thought. So I'm going to replace this with get ship mass. And technically I am using it here as well, but this is in the old part of the heuristic that I fully intend to be removing, so it won't matter, but, you know, just in case, for consistency, we're going to go ahead and use that. All right, that makes me feel better about that too. I'm not gonna, as long as I consistently use that, I'm not gonna miss opportunities. I could do a quick search actually in my code for calculate ship mass. I actually want to search current project. Good. I'm only using it in the one place. That is excellent. Okay. So now we know how long it would take the ship, if it were going at maximum speed, to decelerate using only the braking thrusters down to the target speed. That's the first thing I determined that I would need. Next thing I want to know is how much distance will be covered if that happens, which this is similar to this. So we get the position for delta V. Yeah, this is basically, I have another one for it. I just had to know time first in order to calculate it. All right, double what did I, just distance, yeah. Distance from max speed to target speed is kinematics dot get position delta v. Again, we're going from max ship speed to the projected goal speed. Oh, hold up. Oh, wait, initial position. Oh, initial position is just 0 in this case, because I only care about the, yeah, we're starting from 0, but the equation includes, you know, it's your new position is based on your starting position times the average of your two velocities times time. But we only care about the distance covered, so we're effectively starting from 0. Yeah, so 0, there we go. Initial velocity, max ship speed, final velocity, projected goal speed, and time is time from max speed to target speed. And now we have the distance that will be required to make that change. That distance plus distance to max speed is less than the goal distance. Easy calculation. Yes, cool. All right. So now, I guess maybe it actually would have made more sense to do this first. The reason I didn't write it down on my list is because I've already done this, sort of. I also want to know the time it would take to accelerate from our current speed to the maximum speed, which is mostly just going to be this. I'm just going to copy this. And I'm actually going to put it in front of this one. Max acceleration is a little different. I'm gonna not use this variable. Our acceleration is going to be the max gas thrust divided by get ship mass. And in this case, we do in fact want that to be positive. But that was the same, that was the same calculation I used here. But we're only looking at one thruster at a time. So it's that thruster's max effective thrust divided by ship mass. In this case, it's the sum of all of the thrusters giving us forward thrust divided by the mass. That's our acceleration. So now we know the time it takes to reach max speed, 100 meters per second, as well as the time it takes and distance it takes to go from maximum speed back down to 0, or back down to whatever we want to end up. Because, I think I mentioned this before, the fastest way to get from where we're going to where we want to be and end at that right. Well, the fastest way to get there is to be at max speed as much time as possible. So we want to accelerate to max, and then we want to go down to our target velocity at the very last possible second. And that's what we're calculating here, is the heuristic is the guess at the best possible outcome we could achieve. Knowing that that's likely not possible, especially if there are obstacles or whatever. But if there are no obstacles, this might actually be exactly possible, and we want to know that, because this will be our good guess. All right, so now we know. So the reason that we calculated both of these and all this is that if the distance it takes to get to max speed added to the distance that it takes to get from max back down to our target is less than the distance to the goal, then this is exactly what we want to do. We want to go up to max, stay there for as long as we need to, and then roll back down, because we have space to do that. That's actually the easy math. If that's not the case, if there's not enough space between us and the goal to do all this, that means we don't actually have enough space to go all the way to max. But we're going to have to figure out how high we can go. And we'll do that in a second. So first, let's check if we can do the easy calculation. So distance to max speed plus distance from max speed to target speed is less than the distance to the goal. And I should have done this, right? I guess I haven't actually calculated this precisely, but we do have our projected axis goal. So this is the final actual goal position projected onto this axis, the only thing we can care about. And we do know our current position because it's part of the state that's passed into this function. So we have the distance between the projected axis goal and state dot position dot length. So it doesn't actually matter if I do goal minus current position or current position minus goal, because the length is going to be the same. They're just going to be opposite directions, but once we calculate the length, it's the same. But this just feels right to do the goal minus the current position. Yeah, so if this distance is shorter than that, then we have space to reach max speed. There is space to reach max speed first. Else, ship will never reach max speed. Find the, I don't know, what would you call that? The reverse point, I guess. Find the reverse point. So if there's not space to actually get up to max speed, we still want to get as fast as we can before having to start braking. We'll just have to find out where that is. And I have some, I think I can get there. I haven't done that math yet, but I'll have some help. So if there's space to reach max speed first, this is going to look a lot like some of the calculations I've already done. It's going to look a lot like this. Right, we've already done most of the math. So we can basically break up. What we want to know is the total time it takes to reach the goal. That's the important part. And that time can be broken up into 3 parts in this case. The first part will be the time that we spend accelerating. The second will be the time that we spend just chilling at max speed. And the third will be the time that we spend decelerating, braking. Fortunately, we've already calculated the time we're going to spend accelerating, and we've also already calculated the time we're going to spend braking. So all we have to do is calculate the time that we have to spend coasting at maximum speed. And that is going to be determined by mainly the remaining distance. So let's just do this first. Let's do double coasting distance. And that'll be, should I just make this a thing first? I'm going to use this multiple times. Yeah, we're going to just calculate a variable once. Let's go back up here. Double distance to goal is that. So we're going to have to use that multiple times, so I might as well just do it. Do the math once and go here. So the coasting distance will be the distance to goal minus the distance to max speed. That's an equal sign, not a minus sign. Minus the distance from max speed to target speed. Coasting distance double coasting time is the coasting distance divided by max ship speed meters per second. That's right? Coasting distance is in meters, divided by meters per second, results in seconds. Yeah, perfect. That's our coasting time. Our total time, I'm just setting this to a variable, right? Max time, time cost. Right. Setting to be there. Because it kind of doesn't. That's fine, we're getting rid of that anyway. Time cost is not distance. Time to max speed plus coasting time plus time for max to target. And so I do want to do something similar to what I did here, where I have a maximum time total thruster activation count. Yeah. Wait. Oh, I already declared those. No, perfect. So max time is math.max time and time cost. So the reason we're doing this is that this is the amount of time it will take to reach our goal on this axis, on this, this third of the goal, this dimension. There we go. That's a good word. Yeah, this is the time it's going to take to reach our goal in this dimension. But there are 3 dimensions, and each of them can essentially operate independently. And not independent, well, sort of independent. They operate in parallel. That's a better way to describe it. So if it takes us, 4 seconds to align to the goal on the x-axis, and it takes us only 2 seconds to align to the goal on the y-axis, but it takes us 6 seconds to align to the goal on the z-axis portion, the whole thing is only going to take 6 seconds, because by the time that the z-axis is aligned, the x and y portions will already also be aligned. So we only care about that maximum. On the other hand, we also are going to count the total number of times we're going to activate thrusters. And that's activating them per step that we're evaluating the position. This is something I actually should have described at some point. The way that the A-star algorithm works is that we're looking at... Did my sound just cut out? I don't know. If it did, it's back now. We're looking at... How do I describe this best? I probably should just pull up Wikipedia and do that more easily. Yeah, I'm dividing the algorithm up into steps that are 1/6 of a second. That's because Space Engineers as a game, it is already divided up into ticks, and a script can only run at most once per tick, and a tick is 1/60th of a second. So I'm basically reevaluating the position every 10 ticks. And so what I'm doing is I'm taking every combination of thrusters. So, say, all right, I want to activate the rear thruster only. And I say, okay, if I activate the rear thruster for 1 tick, where am I at the next tick? And is that better? The heuristic function is asking, is that better? I'm also going to try activating just the right thruster for 10 ticks, 1 time step. I think I said 1 tick again before. For 1 time step, 10 ticks, and say, is that better? I'm also going to try activating the rear thruster, the top thruster, the bottom thruster, and the left thruster all at once, and have those going for 10 ticks, and see, is that better? And essentially, this heuristic is going to tell me that one of those is better than the others. And we're going to look at that one first. And from there, we're also going to activate just the rear thruster for 10 ticks and see what that looks like. Just the upper thruster for 10 ticks and see what that looks like. And it's kind of spreads out and looks at all. It theoretically could look at all possible positions, but it's going to start looking with the ones that are most promising. And yeah, so that's what we're trying to do. And so the, all of that, well, all that's very useful for the context of this whole thing in general. And I wish I had explained it last time because that's actually, I feel like, kind of important to understanding what I'm doing. And again, ask questions. I don't know if things pop up on my screen, but nobody's posting in chat. That's fine. But ask questions if you want to know. I'd love to explain it. But yeah, so I want to know how many times we activate a thruster, and each of those activations is considered to be for one step of time, which in this case is 10 ticks. And that's because sometimes activating the rear thruster, you can activate the rear thruster and you'll go a certain distance forward. You can also activate the rear thruster, the left thruster, and the right thruster all at once, and you'll actually go to the exact same position because the thrusts from the left and right are just going to cancel each other out. And so you're going to go to the same place in the same amount of time, which means time alone is not quite enough to say one is better than the other. The algorithm's actually going to look and say, oh, these are both good. These are both equally promising because they took me to the same place in the same amount of time. But I've added this in so I can say, yeah, they took the same place in the same amount of time, but this one activated 3 thrusters instead of just the one that the other one did. Let's just evaluate the one. And that saves a ton of time in the algorithm actually finding our optimal goal. So that's what that is. So we've calculated the time it takes. Well, in one case, if we have time to accelerate to max speed and then come back down, we already know how long that will take. I also need to know how many thruster activations that will take. And I should essentially have this figured out. Right. So, yeah, that makes sense. Sorry, let me explain. So this case, in my old heuristic, where I was just evaluating one thruster at a time, this is the more similar case to what we're doing right now, because in that case we spent time accelerating to max speed and then more time coasting at max speed. Because in that version we didn't care about breaking back to zero. Just like, I just want to hit the goal. I can be going as fast as I want, but now I want to change that. So what I did there, when you're coasting, you don't have to activate any thrusters. You can, but it doesn't do you any good. So for calculating the heuristic, where we want our lowest guess, where we don't overestimate, we want to assume we're not using any thrusters while we're coasting. But we do want to assume that during the whole time it takes to accelerate, we are counting one thruster activation for each time step, which in this case is 10 ticks or 1/6 of a second. So we have the number of seconds divided by 1/6 of a second, so it's just going to multiply by 6. And I'm going to round up because actually, is that right? Should I be rounding up? Should I be rounding down? I should probably be rounding down, shouldn't I? Because I can't overestimate, or else the algorithm breaks, or it could break. I'm probably supposed to be rounding this down. I was thinking I rounded up because, like, a time step. Oh, that's why I did it. That makes sense. So, because I don't have the algorithm set up so that I can only activate a thruster for a portion of a time step, it's all or nothing of that, of each 1/6 of a second. But this time to max speed is not necessarily evenly divisible by sixths of a second. We could end up with a fraction. And I'm going to be in order to reach max speed, I have to be activating the thruster for its full time. So yeah, no, in the old version, it definitely makes sense to use ceiling. I definitely need to round up because I won't reach max speed if I'm not activating it for that last fraction of a step. I think the same is true here. So the difference here is that there are going to be two. I'm just going to copy this because I'll have to change a couple of the things, but oh, actually, no, I don't. But there are two times when we're activating thrusters. So we are activating thrusters while we are accelerating. Actually, this is still not quite right. Let me do this a little bit differently to make it clear. I might condense the math, but I want to write it so it's clear first. So we have an integer that is steps accelerating. So this is the number of steps spent accelerating. And then steps braking is the same thing, but it's the time from max speed to target speed divided by not that time step. Thank you. I don't like that. The automatic formatting is also a little bit different in here. Sometimes I want the spaces. It makes it easier. It really just makes it easier for me to read because it's what I'm used to reading. I also have noticed that by default, C#'s method names are all capitalized, and I hate it because I'm really used to writing methods that start lowercase. So all of the methods I write are starting lowercase because, again, I'm more comfortable with it, and I can't bring myself to change it because I'm not going to be able to type that way when I type the other way on a daily basis for work. Anyway, okay, so this is the number of steps we'll be accelerating, and this is the number of steps we'll be braking. And I think it's still going to be correct to use the ceiling on both because, again, I'm not setting up the algorithm at the moment in a way that it can activate a thruster for a portion of a step. In fact, I'm probably never going to do that precisely, but yeah, it's fine. So this is the number of steps we're taking, and the reason I wanted to break it into steps first is because we're also, in this case, evaluating an entire axis of thrusters. It's not just one thruster, which is what I was doing the old way. So our total thruster activation count for this axis will be the steps accelerating multiplied by the count of gas thrusters plus the steps braking multiplied by the count of brake thrusters. So when we just have one of each, as we do for the initial basic ship design, it's just steps plus steps. But you know, if we've got 5 forward thrusters and 3 backward thrusters, like then we'll evaluate it correctly based on this. And yeah, and the even though for time, um, only the axis that takes the longest really matters because the others will be done in time. For counting the number of thrusters, we want to know all axes because all of the thrusters are going to be active. So cool. So this should be essentially correct if there's space to accelerate from max speed, coast at max speed for a while, and then brake back down until we reach our target speed. And I believe this math is even correct if our target speed is negative. Like that would we calculated it so that the amount of time it would take to reach a negative speed is still accounts for going past the goal and coming back. I'm fairly confident in that. It might be fun. Might have some fun when we test that. It might be terrible. So the other case, the harder case, is we're going to have to start, if we're just going full gas, then we're going to have to switch gears and start braking before we ever reach max speed. And there's a point of equilibrium there. And we want to know at exactly what speed, or well, specifically, I guess we want to know at exactly what time. Time's all that really matters for this calculation, but we want to know at exactly what time we have to reverse, and we have to know what speed that's going to be so that we can figure out how to get there. So I was going to do this totally off stream because I was going to do it on paper, because basically I'm creating a system of equations and solving it for that missing point of equilibrium, and I figured there's no great way to like do that on stream on a computer. I want to do it on paper, and I don't have anything set up. I'm not gonna draw in Microsoft Paint with my mouse, and typing in mathematical stuff is not usually convenient. Until my wife reminded me of the site Wolfram Alpha, which I probably haven't used since college, and I didn't even use it that much then. But it actually has inputs for mathematical functions and can probably arrange the equations the way I want without too much hullabaloo. But first things first, since I haven't done this ahead of time, I do want to talk through, excuse me, what it is I want to solve for. So I have a couple different equations. Actually, what if I just do this? I can use my thoughts, and I can continue typing out my thoughts here. I'm going to switch the input to not just show a single, not just show, all right, how do I want to do this? Not just show a single program. I'm going to switch, this is probably the easiest way to do this. Instead of capturing the full screen application, I would like you to just capture this monitor. Can you do that for me? Yes, it looks like you can. Next. Done. Cool. All right. Should have my OneNote up. Great. I'm going to keep typing stuff out here first, and then I'll switch over to Wolfram, and we'll come back to Visual Studio. I'm learning all kinds of things about switching my Twitch inputs and all that today. It's great. Okay. So we already went through all this stuff, and this is what we're doing now. We're finding that point at which we switch from forward to reverse. So I've started making some notes, and then I didn't go any further than that. because I was going to do it separately, and now I'm going to do it here, so it's fine. So for my own reference, we got, I should probably put this up here instead. Oh, please don't. I don't actually have a ton of experience in OneNote either, to be fair, but this seemed like a great way to organize my thoughts for this project, so trying it. So I'm using just plain old D as the distance from the current position to the goal, and we already know that. Calling D0 the distance from where the ship currently is to this unknown swap point. And D1 is the distance from that swap point to the goal. So we know that D0 plus D1 has to equal D. That's the first equation in our system. We also know that the speed at the end of the D0 length has got to equal the speed at the start of the D1 length. And I should have a useful equation for that, maybe. Maybe. I mean, there are a bunch of equations. All right, I'm gonna write out a few of them and see what I can find. I think looking at this delta v, get time delta v and get position delta v, the same ones I was using earlier, I think are going to be useful. So time, so t0. Oh no, can you stop doing that? OneNote, I don't want you to capitalize. Son of a bitch. Okay, anyway, I'll come back, or I'll just leave it. So t0, meaning the time it takes to travel from our current position to the swap point, is final velocity, which is going to be, I'm actually going to capitalize this, the velocity at the swap point. This is here, the velocity at the swap point minus our initial velocity. There's probably a subscript. It's fine. Divided by acceleration, right? Yeah, and we know that acceleration. That's our gas thrusters. The time it takes to go from the swap point to the goal is going to be the velocity at the goal minus the velocity at the swap point divided by our braking acceleration. These are different accelerations. I need to label. Divided by our braking acceleration, which we also know. The only variables in here are the times and VS, which we're still looking for. Okay. I think that's fine. Then we'll look at this one, which we would know. Would we know? What do we know? I guess we're going to find out. I think Wolfram can just solve this whole system of equations if I plug them in. I should be able to do it by hand, but, you know, we'll see. Well, I haven't really been paying attention to where chat is on my screen. I guess it's not really blocking anything super relevant in Visual Studio, though. That should be fine. Is it blocking OneNote? Oh, it's just blocking the stuff we already did. Okay. Sorry that that's there. I could probably move it, but it doesn't look like it's too bad. I didn't have any chat there last time, but I kind of wanted to throw that command out there to encourage people to ask about what's going on if they want to. Okay, so let's look at this. So, right. Yeah, this is the same one I was using before. I don't necessarily care about every aspect of it. So that D0, that initial distance, is half of the velocities added sum together, right? Yeah, because it's the average. So it's v0 plus vs times time, right? Yeah. And the second distance will be the same. Half of final velocity plus vs times time. All right, so I have a bunch of equations. These are, okay, I'm going to, let's see, I'm going to bold the things I don't know. Wait, I do know that. I don't know this. Because I need to be able to keep track of this. Because a lot of these are, right, speed at end of z0 equals speed at start of d1 equals vs. Oops. This is what we're trying to solve for, is vs. Well, I guess I'm trying to solve for the whole thing. I guess I'm actually trying to solve for d0 and d1. Yeah, realistically, those are the ones I actually care about. Okay, so I don't know t0 or, come on, or vs. Don't know t1 or vs. Don't know d0, vs. Oh, this is t0, t1. I don't know any of these. Okay. But t0, and t1 can easily just be plugged in here. So let's just do that. Let's do that, because I think that will make my life easier. For understanding what I'm doing. I like that. So I believe this is solvable. I have three variables, d0, d1, and vs. And I have three equations. This one, and this one. All of the non-bolded items are known. They're constants. So I think this is a solvable equation. So, a solvable system of equations. So, how do we go about doing that? Let me just do a quick search. Wolfram alpha solve system equations. How do I want to input that? They have a system equation solver. Awesome. Okay, except is this actually going to do what I want? Because I'm not going to be able to actually enter these as constants, because they're still variables. I don't know. Let's see what happens. Let's see what happens if I just put these in. In theory, this notation is actually compatible with stuff, hopefully. Like, I want to tell you that I want to solve for d0, d1, and vs in terms of everything else. All these are like, I don't have anything really stupid, do I? I think these are all fine. Are you just going to tell me this is not valid? Oh, use a system of 3 equations instead. Thank you. All right. Okay, this is related. D1 equals D minus V0. Okay, I know V0 and V1. Oh shoot, it's calling VS. It's turning VS into two variables, V and S. So we're gonna call, yeah, we're just gonna call VS V then. What if I make it a lowercase v? Is that fine? It doesn't matter. It doesn't matter. Try this again. Yeah, I don't want S. Okay. These aren't, yeah, these aren't quite what I had in mind. Which I understand. This is kind of a mess. I might have to actually do this by hand. Because there's, yeah. Oh, it's been a long time. It's been a long time. Um, hmm. I mean, it should come out the same, I guess, but I guess I could also just get rid of the D0 and D1 variables and just say, hey, this plus this equals something. I mean, D, but yeah, actually, maybe I should try that. Actually, solve D equals this plus this for V? Will you let me do that? Oh, it does. Oh, it actually does. You're so, oh, this is helpful. I mean, this is a nightmare. I might need to, yeah, okay. Plus or minus A0. Oh, this looks very much like a quadratic equation. That makes sense. It probably should. Show me your step-by-step solution. I have to go pro to see the step-by-step solution. Hint, thanks. Hint, rewrite the right side of the equation. You mean this is, you want me to rewrite that? I can't imagine. I can't imagine why. Yeah, okay, I get it. If I factor that out into a quadratic equation, and I have a formula for solving the quadratic equation, and one that's apparently more computer appropriate. Gets less rounding errors. When because apparently if I don't know, I'd have to look it up again. Like if your A or C coefficients are really close to 0, you can get really terrible rounding error doing this math on a computer, thanks to floating point numbers. All right, yeah. Ugh, gotta do this manually. Fine. You guys don't want to watch me do this manually. Of that, I'm pretty confident. How long have I been going? Almost 2 hours. Wow, that's surprisingly. Okay. I mean, we still made a lot of progress. Um, and I mean, I should get some sleep. So maybe this isn't the worst thing. Maybe this isn't the worst thing. Um, yeah, yeah. I'm gonna get some sleep sometime in between, life, getting sleep, doing work, taking care of a child, just, everyday stuff. Some point I will find the time to break out my old algebra skills and solve this. I can see, I got to FOIL out the whatever these are called, and I mean, I just turn it into a quadratic equation. I find my coefficients, and it's fine. And I just plug it back into the kinematics equation I already have. Um, I might turn this into a more, I might make a more generic thing that's just the quadratic equation solving, and um, call that from this so that I can also call it from this new function I'll have to make. Um, yeah, no, that'll be good. Um, and yeah, we can do that. I like that. I like that plan. It won't take me that long. I just don't want to do it on stream. Sorry. Plus, this is a good excuse to call it. So, yeah, that's gonna be me. Man, this was great. I I like I like talking through what I'm doing, because I have a tendency to not. Well, I mean, understandably, working on a project alone in your office, most people probably aren't going to talk to themselves through the whole thing. I'll admit I'll talk to myself through part of it, um, but sometimes, causes my brain to jump around to all kinds of things, and I get lost on what I was doing and whatever. But actually talking through this to the benefit of theoretical viewers um, is kind of helpful in focusing those thoughts. Uh, yeah, I feel like I got a lot done. I like the start of our updated heuristic function, and I have a good feeling that it's relatively accurate so far. I'm not even remotely looking forward to testing it. That's going to be a nightmare, but it's okay. It'll probably work on the first try, right? Right? Newly written code always works on the first try. I don't know what you're talking about. Anyway, I'm just rambling now. Yeah, like I said, I'm gonna do that algebra off stream so that I can come back with a clean slate. We'll get this going. Honestly, the next time I stream, I should at least get to the point at which I can test this new heuristic, and I'll run through everything, make sure I'm not missing anything else. I think the heuristic function is the main thing I have to update. Um, and then yeah, we'll see what it does. See what it does. I'm excited. Yeah, that'll be great. Cool. Looking forward to it. Hope you had some fun watching this stuff. Maybe even learned a thing or two. Like I said, I'll be back. Ask me more questions. Ask me all the questions. I think this stuff's so much fun. I'd like other people to think it's fun too, just because, I don't know, just because I'm excited to talk about it. But anyway, I'm going to stop rambling and I'm going to say goodnight. Hope you all have a great long rest, and I hope you recover all of your spell slots. Good night.